Okay, well, I figure we'll go ahead and get going here. Again, welcome to EXAIR's fall webinar. This is compressed air safety and NIOSH hierarchy of controls. And here we go. First, I just want to jump into a little bit of presentation housekeeping. If you've been to one of our webinars before, that's very similar. Same format, same platform, so it should be pretty easy for you. There is a questions button on the window that's open, the GoToWebinar window that's open on your control panel. Somewhere near the note A, you can see there in that photo. You can ask questions throughout the webinar. Russ Bowman will be on the line to answer those questions to you back directly. And then we'll review some of those questions at the end as a group if any do come in. If you have any trouble with audio or video throughout the presentation, please let us know through this same window, and we will see what we can do to help. In the event that you lose connection or need to sign out of the webinar, there will be an on-demand version available shortly after this presentation. We will send out an email to all registrants with that link. So no worries if you something happens, you lose connection, you'll be able to see a recording of this presentation shortly after. Under the handout section, you'll see there should be 3 handouts there to download. Those handouts are some of our catalog sections for some of our air knives, air nozzles, and our safety air guns, which will play a major role in today's presentation. So you can download those and view those at your earliest convenience. If anyone could just shoot me a quick note saying that you can hear me, everything sounds good, we will jump into the main part of the presentation. All right. We will go ahead and get going. So first, a little bit about EXAIR. EXAIR is a manufacturer, direct seller, and global distributor of engineered point-of-use compressed air products. We are located in the northeast corner of Cincinnati, Ohio, where we were founded in 1983. All products focus on the efficient and the safe usage of compressed air. We design and manufacture all of our products here in our Cincinnati office. Our products are commonly used in cooling, cleaning, static elimination, and conveying processes. In fact, you may be familiar with some of our products like our air nozzles, vortex tubes, cabinet coolers, industrial vacuums, and just to name a few. I mean, we're coming out with new products every year and always getting better and making them better. We do offer the largest selection of end-of-use intelligent compressed air products on the market today. Now a little bit about myself. My name is Jordan Schaus. I'm one of the application engineers here at EXAIR. I joined the team here in August of 2018, and before that, I spent my time in the metrology field. So I would examine customer quality processes, then design and implement a strategy to better the quality and reduce scrap rate across board. When I'm not here at EXAIR, I like to explore the outdoors, so much so that I have a 100-gallon saltwater reef tank in my house. And of course, I spend time with my new wife and our 2 crazy dogs. Much of our focus here at EXAIR is to improve the overall efficiency of industrial compressed air operating processes. Over the course of the next 30 to 45 minutes, I'm going to cover one of the most important topics. First, we're going to learn about the hierarchy of controls in relation to compressed air safety, gain the understanding of NIOSH's prevention through design initiative, understand elimination through substitution, which is the simple process of achieving the most effective implementations for compressed air safety, and then we're going to determine an EXAIR solution for common compressed air applications, so they can reach the highest level of the hierarchy of controls through prevention by design. Now, a little bit of what is NIOSH? What is the hierarchy of controls? Well, the National Institute of Occupational Safety and Health is commonly referred to as NIOSH. In the U.S., It is a U.S. federal agency that conducts research and promotes safe working through recommendations and collaboration. The institution, which is a part of the U.S. Center of Disease Control and Prevention, also known as the CDC, was established in 1970 at the same time that the Occupational Safety and Health Administration, OSHA, was established. As indicated on the CDC website, NIOSH works to assure every man and woman in the nation safe and healthful working conditions and to preserve our human resources. The hierarchy is one of many safety-focused strategies developed by NIOSH and originates from NIOSH's Prevention Through Design initiative. The initiative purpose is to prevent or reduce occupational injuries, illness, and fatalities through the inclusion of prevention considerations in all designs that impact workers. Eliminating hazards, redesigning processes, or implementing preventative measures to control worksite hazards are some of the core methods of prevention through design that are shared within the hierarchy of controls. While the hierarchy of control strategy is in order of effectiveness, all 5 methods of control should be considered as they often work best in combination. Training workers on identifying possible hazards and proper control methods to deal with those hazards is the best way to promote safety at the worksite. Now the hierarchy of controls. The idea behind the hierarchy is that the control methods at the top of the graphic are potentially more effective and protective than those at the bottom. Following this hierarchy normally leads to implementations of inherently safer systems, where the risk of illness or injury has been reduced. NIOSH leads a national initiative called Prevention Through Design to prevent and reduce these occupational injuries, illnesses, and fatalities through the inclusion of prevention considerations in all designs that impact the personnel. The hierarchy is a prevention through design strategy. So the top 2 sections of the hierarchy of controls, elimination and substitution. While typically these are the most effective at reducing hazards, they also tend to be the most difficult to implement in an existing process. If the process is still at design or development stage, elimination and substitution of hazards may be inexpensive and is simple to implement. For an existing process, major changes in equipment and procedures are sometimes required to eliminate or substitute for a hazard. We will see some easy and highly effective examples from EXAIR that reach these high levels later in the presentation. Engineering controls are favored over administrative and personal protective equipment for controlling existing personnel exposures in the workplace, because they are designed to remove the hazard at the source before it becomes in contact with the worker. Well-designed engineering controls can be highly effective in protecting workers and will typically be independent of personnel interactions to provide this high level of protection. The initial cost of engineering controls can be higher than the cost of administrative controls or PPE, but over the long term, operating costs are frequently lower, and in some instances can provide a cost savings in other areas of the process. Administrative controls and PPE are frequently used with existing processes, where hazards are not particularly well controlled. Administrative controls and PPE programs can be relatively inexpensive to establish, but over the long term can be very costly to sustain. These methods for protecting workers have also proven to be less effective than other measures, requiring significant effort by the affected personnel. Even with significant effort, people do forget to use PPE or use the PPE incorrectly fairly often. Prevention through design. Prevention through design encompasses all of the efforts to anticipate and design out hazards to personnel in facilities, work methods and operation processes, equipment, tools, and products, and the organization of work. The focus of prevention through design is on workers who execute the designs or have to work with the products of the design. The initiative has been developed to support designing out hazards, the most reliable and effective type of prevention. The approach that will be used to develop the implementation of the Prevention Through Design National Initiative will be framed by industry sectors within 4 functional areas. First, research, then education, then practice, then policy, as the image indicates above. This process encourages stakeholders' input throughout this sector-based approach. So now we're going to do a little bit more of a deeper dive into the the 5 sections of the hierarchy here. First is elimination. So again, elimination is physically removing the hazard. It's a straightforward strategy that should be implemented before all other methods are considered, and is considered the most effective of the 5 sections of the hierarchy of controls. According to NIOSH, elimination is the easiest to implement at the design and development stage of a project. Addressing elimination at the start allows designers and planners to make large changes easily without needing to retrofit a process. The next best way to control a hazard is through substitution. Substitution is replacing a material or process with another that is considered to be less hazardous. To be an effective substitute, the new process or material must remove or at least mitigate the hazard. Like elimination, substitution is most effectively implemented in the early stages of a project, since they both depend on drastically changing the equipment or procedures of the project. Substitution and elimination become more difficult to implement the further along a process is in development. So here's one example of a open-ended air fitting that EXAIR was able to eliminate this hazard through the hierarchy of controls. So an open-ended blow-off is not only unsafe to the operator, but also to their hearing. These were eliminated with the use of 2 1101s super air nozzles. They not only brought the operation into OSHA compliance, dead end pressure, and hearing pressure safety standards. It also saved over $7,000 annually on compressed air costs. If this was designed from the start, they could have saved over $28,000 over 4 years and had a safer working environment for their personnel. A tier 2 automotive supplier was using these cross-drilled air guns widely across their facility. While these guns complied with OSHA dead end regulations, they came in at 104 decibels and nearly consumed 50 SCFM. To put that in just to a little perspective, that's the sound of a lawnmower with your ears about 3 feet away from it. So pretty loud. So we replaced them with our soft grip safety super air gun with a super air nozzle. They are dead end pressure compliant and drop the noise level down to 82 decibels. To put that into perspective, that's the sound of a vacuum cleaner 10 feet from your ear. And they only use 35 SCFM. So again, saving compressed air generation costs as well. Another source of elimination, a local company here, they were using these liquid nozzles to blow water off a product they produce. The issue with using liquid nozzles is they are not designed to be used safely with compressed air, and because of that, they are loud and inefficient, and put the operator at risk if they were to be dead-ended. We replaced them with 2 EXAIR 2-inch flat super air nozzles. Not only are they OSHA compliant in regards to dead end pressure, like all of our nozzles, it also lowered the noise level by 18 decibels, and it completed the task better. Engineering controls. Workplace hazards often cannot be eliminated or substituted, especially when the project is further along in development. In this case, the best next option is implementing an engineering control. Engineering controls are used to isolate personnel from the hazard. The initial cost of engineering controls can be higher than some other methods, but the long-term operating costs are frequently lower, and there are often additional cost savings in other areas. These controls do not interfere with personnel productivity or personnel comfort like personal protective equipment commonly does. Installing machine guards that shield personnel from airborne emissions is an instance of an engineering control implementation. This is a highly effective engineering control because it places a physical barrier between the workers and the hazard and can be implemented independently of any worker interaction. Those looking for engineering control ideas are recommended to visit NIOSH's website, and they have an engineering control database, which has information on engineering control technologies. Here's a good example of a engineering control. This is a very common thing in chemical facilities. This is a fume vent, and it can be installed as a machine guard that shields the personnel from the airborne emissions that could occur. This is a highly effective engineering control because it places a physical barrier between the personnel and the hazard. administrative controls essentially change the way people work. This limits exposure to the hazard rather than removing it. Because the hazard is still present, this method is considered less effective than the previous three. Although administrative controls can be used to control employee exposure, they are prone to human error and cannot always be relied upon to reduce exposure. Administrative controls include employees' training, signs, label warnings, and procedure changes. A common example of an administrative control is conducting road construction at night when there are fewer drivers on the road. By changing the work practices at the road construction site, worker exposure to hazards can be reduced. The final section of the hierarchy is the implementation of personal protective equipment, also known as PPE. This is effective and easiest and most common way to mitigate worksite hazards. However, PPE does not eliminate the hazard and may result in workers being exposed if the equipment fails or is used incorrectly. PPE, as well as administrative controls, can be relatively inexpensive to establish, but can be very costly to sustain. These methods for protecting workers have also proven to be less effective than other measures, requiring significant effort on the part of the worker. PPE includes gloves, hard hats, safety glasses, high-vis clothing, and other protective garments and equipment. While personnel protective equipment has great value, it is not the most desired mechanism in the hierarchy of control. Having all of these controls in place is great, but you are still relying on the worker to use the PPE and to use it correctly. So here's an EXAIR product to help you along the way to fully control your environment. It is the EXAIR digital sound level meter. It's an easy to use instrument that measures and monitors the sound in a wide variety of industrial environments. The source of loud noises can be quickly identified so that the corrective measures can be taken to keep sound levels at or below the OSHA maximum allowable exposure limits. The factory comes directly from us with a NIST certification. So it's a great tool to utilize to find those loud operations and replace them with a designed nozzle like we offer to drop the noise level to keep your employees safe. So in this webinar, we have explained the main elements of the hierarchy of controls and illustrated several ways to reach the highest level of control in regards to the important compressed air safety standards. Best used in this order to provide the best safety result for personnel. First, we want to eliminate the hazard. As covered a few slides ago, this can be easy as replacing a non-OSHA compliant blow-off with a EXAIR intelligent compressed air product like our super air nozzles. Second, we want to substitute something in place of the hazard, like how we substituted the safety air gun in for the loud, inefficient one. And third, we want to isolate personnel from the hazard if it remains with engineering controls, like the fume vent we saw on slide 18. And fourth, administrative controls essentially change the way people work. Here we're going to write a procedure that excludes the hazard from the personnel's operation. And fifth and finally, PPE. Supplying the correct personal protective equipment for personnel to protect themselves from a given hazard. Worksite hazards can be mitigated in a wide variety of ways, but by implementing the hierarchy of controls and the Prevention Through Design initiative, employers can work with their employees to determine which way is the most effective and safe for their circumstances. So if you have any questions, please feel free to send them in via the chat or give us a call. We will do our best to address them. In closing, EXAIR has a full team of subject matter experts that are willing to help with your applications. Feel free to reach out to myself or any engineer for assistance with any questions you may have. We have 5 of us here in the US and Canada application engineering department, and then we have 2 down there in the international. So wherever you are, we're here to help, and we can help you pick a product that's going to help you control your process in a safe manner for you and the personnel working with that system. So thanks for joining, and have a great rest of your day. The next slide, I'll wait in for a couple questions, and I can read them here and answer them here. Here's a pretty good one. Are EXAIR's safety air guns and nozzles OSHA safe? Yes. So in combination with using our safety air gun and our super air nozzles, they meet OSHA dead end pressure standard 29 CFR 1910.242B and noise level exposure standard 29 CFR 1910.95A. Our air guns and our nozzles can operate at full pressure to maximize force and velocity of the air. And there's a follow-up question there. It says, what makes our super air nozzles so super? Well, the super air nozzle has been engineered and designed to dramatically reduce sound levels and compressed air costs while providing excellent blowing force for your application. It's got a decent one. Hi, I'm looking for a suitable safety air gun and nozzle for cleaning heavy machinery, radiators, in a very dusty environment. We have a wide selection of safety air guns, including our heavy-duty safety air guns that would be very well suited with heavy-duty industrial areas. Specifically with radiators, we've had great success using our heavy-duty safety air gun with our 2-inch safety air nozzle to really get penetration in between those radiating fins to clean them out as much as possible. So yeah, I will take your name and your information down, and I'll shoot you an email after this presentation with what is a good, suitable gun for you, and we can start the conversation there. And it looks like I have one more in here. Will a super air nozzle fit on air guns that we already have in-house? Typically, yes. All of our safety all of our nozzles are available independently. However, many typical air guns have an internal restriction that limits the output pressure of the gun to less than 30 psig in order to comply with OSHA dead end pressure requirements. Our nozzles are already compliant with those standards, so there's no need to limit that to 30 psig. So these air guns will typically not work properly with the EXAIR super air nozzles. EXAIR super air nozzles meet OSHA dead end pressure requirements, therefore we don't need that restriction in the gun itself. So the EXAIR safety air guns are designed for best performance with our super air nozzles, but it's absolutely a possibility. I had another one come in here. Is it possible to get a 6-inch air knife with a back inlet? Yeah, absolutely. Our super air knives have inlets on each end and the bottom. And then we also have 2 other lines of air knives that one does have a back inlet on for it. We also are the manufacturer of all of our products. So you know, the customization of all of our products is super easy. You know, if you have a specific application that it needs in a specific spot, you know, we can design that. We can make it custom for you as well. But I bet you we do have a stock solution for you there. And I got your information here, and I will shoot you an email after this presentation with the options that we offer. Not a problem. All right, well, that's the last questions that I have. I'll hang out here just for a few more minutes. And oh, here we go, another one just popped in. So we do not have a pulse valve specifically for use with our safety air guns. What we do have is we have one of our safety air guns the ability, what we call our Vari-Blast safety air guns. The Vari-Blast is going to provide a variable amount of air coming out of the air gun based on the amount you pull the trigger. So if you pull it halfway, you get about 50% of the power of the gun. If you pull it full all the way 100%, you're gonna get that full power of the Very Blast safety air gun. But the actual pulse valve, I do think I know what you're talking about. We do not offer that with any of our safety air guns. But I will. I have your information here. I'll send you an email after this, after the webinar today, with our Very Blast information, including our whole catalog section for our safety air guns. All right. Well, I will go ahead and end this out today. Like I said, if you want a copy of this, there will be one emailed to you in the next couple days. You'll get a copy of that in a thank you email. But I do appreciate everybody for coming out, and you have a great rest of your day and a great weekend, and be safe.